Welcome back, everybody. Today we're doing a deep dive on state transition testing.
Yeah,
I think everyone listening probably has a pretty good understanding of the basics of software testing.
right.
But this is one of those techniques that kind of adds a whole new layer on top of everything.
Yeah, it really does.
It's all about how software reacts to different inputs,
hmm
especially when the order that those inputs come in really matters.
Yeah, and what I think is so interesting about this technique is that it's not just about finding bugs.
Right.
It can also be a really great tool for communication,
Oh, absolutely.
visualizing how the system behaves.
Right.
Make sure that developers, testers, business stakeholders, everybody's kind of on the same page.
Yeah. And that's valuable throughout that whole development life cycle.
Absolutely.
So to make sure we really understand all this, we've got some diagrams and tables
Yes.
from the sources you provided, which are going to help make it crystal clear how this all works in practice.
It's like creating a roadmap for your software that shows all the different routes and destinations.
Love it. Okay, so let's break this down. Let's get to the core concepts here.
Okay.
Can we walk us through like the key elements of these state transition models?
Sure. There are four main parts.
Okay.
States, transitions, events, and actions.
Okay,
And states represent all the different conditions that your software can be in.
got it.
For example, in a login system, you might have states like logged out password reset.
Okay, so the software is always in one of those states.
Yes,
Okay.
always in one specific state.
At any given time.
Yes.
How does it shift between these different states, though?
That's where transitions come in.
Okay.
Transitions are the pathways between the states.
Got it.
They're triggered by specific actions or inputs.
Okay.
So think of it like clicking a button to submit a form.
Okay.
That click is an event that causes the system to transition from maybe a form incomplete state to a form submitted state.
Okay, so the event is what kicks it off, and the transition is the actual movement
Exactly.
between the states.
Yes.
What happens as a result of that transition, though?
That's where actions come in.
Okay.
Actions are the outcomes or responses
Okay.
that occur when a transition takes place.
Got it.
So, for instance, if the transition's successful, the action might be displaying a confirmation message.
Okay.
Or loading a new page, or if it fails, the action could be an error message,
Right.
or prompting the user to try again.
So we have the state that it's the event that triggers the change, the transition or the movement between the states.
Right.
And then finally the action, which is the outcome of that transition.
Exactly.
It's like a chain reaction.
Precisely.
Each step leads to the next one.
And to make sense of this chain reaction, we use visual representations,
Okay.
like state transition diagrams and tables.
Awesome. So let's actually dive into an example here
Okay.
to see these concepts in action.
Okay.
So let's imagine using like a mobile banking app.
Okay.
Could you walk me through what a state transition model for transferring money might look like?
Sure. Let's say you start in the home screen state.
Okay.
You tap the transfer money button.
Okay.
That's the event.
Got it.
This triggers a transition to the enter transfer details state.
Okay.
And here you input the recipient, the amount, any other required information.
Okay. So I filled in all the details of what happens next.
Then you would tap confirm.
Okay.
That's another event.
Okay.
Now, depending on the validation rules of the app, this could lead to a confirmation successful state.
Okay.
And then it would move on to process the transfer.
Right.
Or if something's missing or incorrect, it could transition to an error state.
Okay.
And you'd have to fix the issue before proceeding.
Interesting. So the diagram would actually show all these different paths and potential outcomes
Exactly.
based on the user's actions in the app's validation.
And what's really helpful here is that it forces you to think about those edge cases.
Yeah.
Like what happens if someone enters an invalid account number or they try to transfer more money than they have available?
Right.
Those scenarios might not be immediately obvious, but by mapping out the system in this way, they come to light.
So we're not just testing the happy path, we're testing all the potential.
All the detours, the dead ends.
Yeah. The what ifs. I'm certain to see how this is so valuable for catching those potential problems early on.
Absolutely. One of the biggest wins I've seen with this technique is uncovering those tricky edge cases during the design phase,
Yeah.
which is much less costly than finding them after the software is released.
Oh, yeah, for sure. Okay, so now you also mentioned state transition tables as well.
Yes.
How do those differ from the diagrams?
So while diagrams provide that visual overview of the system's flow,
Okay.
state transition tables offer a more structured, systematic approach.
Okay.
It's essentially a matrix that lists every possible state and event combination.
Got it.
It shows us where we end up after each action.
So if The diagram is the roadmap.
Right.
The table is like the detailed itinerary,
A great way to put it.
making sure we don't miss any stops along the way.
Yeah, imagine a table with rows representing the different states, like home screen enter transfer details, confirmation successful error,
Okay.
and columns representing the possible events.
So the table would show us what happens when we click confirm from each of those states.
Precise.
Is there anything in the table that might surprise us or?
What's interesting here is how the table can reveal scenarios that might not be immediately obvious from the diagram alone.
Okay.
For example, what happens if a user tries to hit the back button during the confirmation process? Does it take them back to the previous screen, or does it cancel the entire transaction?
Wow, I never thought about that.
The table forces us to consider all those possibilities
Right.
and define the desired behavior for each one.
It's like having a safety net,
Right.
ensuring that every possible combination is accounted for.
Exactly.
It seems like the table and the diagram work together to provide this really comprehensive view of the system.
Precisely, they complement each other,
Yeah.
providing both a visual map and a systematic checklist to guide our testing efforts.
This is already making me rethink how I approach software testing.
Yeah.
I can see how understanding these concepts can really help me design more thorough and effective test cases.
You know, I've seen teams really struggle with testing because they just don't have a clear understanding of the system's behavior.
Right.
And state transition testing provides that clarity,
Yeah.
which leads to more efficient testing and ultimately a more robust product.
Okay, so we've got a good handle on the core concepts here
Yes.
and the value of these visual representations.
Right.
Now let's actually take a look at some real-world examples from the sources that you provided.
Okay.
And let's start with, I think, a classic scenario, the ATM.
Yeah, the ATM.
Okay.
So let's picture that ATM scenario.
Okay.
You walk up to the machine, you're ready to withdraw some cash.
Yep.
Initially, the ATM is in an idle state,
Okay.
just waiting for you to insert your card.
So that act of inserting my card is what kicks things off.
Exactly. That event triggers a transition from that idle state to the card inserted state. Now the ATM is ready for your PIN.
And if I enter the correct PIN,
Then we transition smoothly to an access granted state.
okay.
The ATM might show you a menu of options like withdrawing cash, checking your balance, or depositing a check.
Okay, but we all know those moments where we can't remember our PIN correctly.
Right.
What happens then?
That's where things get interesting. An incorrect PIN entry is also an event.
Yeah.
But it leads us down a different path. The first incorrect PIN might transition the system to a first incorrect attempt state,
Okay.
maybe displaying a warning message.
So the system's behavior changes based on that previous incorrect attempt.
Exactly.
I'm guessing the diagram would show this kind of branching off in a different direction.
Absolutely. The beauty of the state transition diagram is that it visually captures these divergent paths,
Yeah.
making it easy to see how the system responds to both correct and incorrect inputs.
Yeah.
Now, let's say you enter another incorrect PN.
Oh,
That event could trigger a transition to a second incorrect attempt state, maybe with a stronger warning.
okay. And if I make a third mistake?
Well, at that point, many ATMs transition to an account-locked state,
Oh, no.
preventing further attempts to protect your account from unauthorized access. The diagram from your source beautifully illustrates this flow,
Yeah.
highlighting that critical path to account lockout.
Ouch. I think we've all experienced that sinking feeling
Yes,
at least once.
at least once.
But that's a perfect example of how this technique helps us visualize not just the ideal path,
Right.
but also the potential consequences of missteps.
Exactly. And by understanding these critical paths,
Yeah.
testers can design targeted test cases to ensure that these security measures are working as intended.
Okay, now what about the state transition table for this ATM example?
Okay.
How would that complement the diagram?
So the table would list all the states we've discussed.
Okay.
Idle, card inserted access,
Yeah.
granted first incorrect attempt, and so on.
Right.
Each row would represent a state, while the columns would represent the possible events.
So each cell on the table would show us what happens when a specific event occurs in a particular state.
Exactly.
So like what happens when I enter my PIN while the ATM is in the card inserted state?
Precisely, the table would systematically map out those transitions,
Got it.
providing a comprehensive view that's easy to follow and verify.
Okay, so I can see how both the diagram and the table are valuable tools
Yes,
for understanding and testing a system like this.
absolutely.
Now let's switch gears and explore a more complex scenario. You mentioned flight reservations earlier.
Yes, imagine you're on a website booking a flight.
Yeah.
This scenario introduces more intricate state transitions because there are multiple steps involved and the system needs to keep track of your choices and selections.
Okay, let's unpack that. What are some of the key states we might encounter when booking a flight?
Well, we start with a search flight state.
Okay,
From there, the user enters their travel details like origin destination and dates, then clicks search.
okay.
This event triggers a transition to a display results state showing available flights.
Got it. So let's say I've chosen my outbound flight. What happens next?
Selecting a flight is another event that triggers a transition likely to a select return flight state if it's a round trip.
Okay.
This sequence continues as you select your return flight, choose your seats, and input passenger information.
Okay, so the system's guiding me through a series of steps,
Right?
each with its own set of choices and transitions.
Exactly.
What happens when I hit that confirm booking button?
That's where things get really interesting. Confirm booking triggers a series of events, including verifying flight availability, checking for any price changes, and processing the payment.
Wow, that's a lot happening behind the scenes.
Yes,
And I imagine there are multiple paths depending on what happens during those checks.
exactly. If everything checks out, the system might transition to a booking confirmation state,
Okay,
generating a confirmation number and sending you an email.
but what if something goes wrong during those checks?
Right.
Like a flight suddenly becoming unavailable or my credit card being declined?
Those scenarios would trigger transitions to different states, perhaps a booking error state or a payment issue state, requiring you to take corrective action.
So the state transition diagram would show all these potential branches and outcomes,
Exactly.
highlighting the critical paths that need to be tested thoroughly.
Precisely. And what's particularly helpful here is that it helps testers prioritize their efforts, focusing on the most crucial transitions and potential points of failure in a complex system like this. It's impossible to test every single scenario, but state transition testing provides a framework for identifying the most important ones.
That's really insightful.
Yeah.
I can see how this technique can be a game changer for testing complex software.
Yeah.
But how would the state transition table be used in this flight booking example?
So the table would provide a systematic way to analyze those intricate transitions.
Okay.
For instance, one entry in the table might show what happens if a user tries to change their travel dates after they've already selected their seats. Does the system automatically reset their seat selection? Does it prompt them to reselect their seats? These are the types of subtle but important behaviors that the table can help us uncover and define.
Okay, so the table acts like a checklist,
Exactly.
forcing us to consider all those potential interactions and ensure we're testing them thoroughly.
It's a powerful tool for ensuring comprehensive test coverage, especially when dealing with a system as complex as a flight booking website.
I'm starting to appreciate the depth and versatility of this technique.
Yes.
We've covered a lot of ground, from the core concepts to real-world examples using diagrams and tables, but I'm curious, are there any limitations to state transition testing? When might it not be the best approach?
That's a great question. While state transition testing is incredibly valuable for many systems, it does have its limitations for very large and complex systems. The number of states and transitions can explode, making the diagrams and tables difficult to manage and analyze.
So it might not be practical for every software project?
Right. And it's also important to remember that state transition testing is most effective when dealing with systems where the sequence of events is crucial.
Okay.
If we're dealing with a system where actions are independent of previous inputs,
Right.
then this technique might not be as beneficial.
Can you give me an example of a system where the order of events wouldn't be as critical?
Certainly, let's consider a simple calculator app.
Okay.
The order in which you press the buttons doesn't really matter. 2 plus 2 will always equal 4, regardless of whether you enter the numbers first or the operator first.
But for something like an e-commerce checkout process, the order is paramount.
Precisely, you need to add items to your cart before proceeding to checkout, and you can't ship an order until the payment is confirmed. The sequence of events is crucial in that context,
Right.
making state transition testing an ideal approach.
Okay, so it's all about choosing the right tool for the job.
Exactly.
I'm starting to see how understanding the strengths and limitations of state transition testing can help me make informed decisions about when to apply it.
And remember, even if you don't use the formal diagrams and tables,
Yeah.
the core principles of state transition thinking can be incredibly helpful in any software project.
That's a great takeaway.
By thinking about the state's transitions, events, and actions of your system, you can gain a deeper understanding of its behavior and identify potential issues early on.
So we've explored how state transition testing can be a powerful tool for analyzing and testing software. But are there any other benefits beyond just finding bugs and improving test coverage?
Absolutely. One of the often overlooked benefits is its impact on communication and collaboration.
Oh,
When you have a visual representation of the system's behavior, it's much easier for everyone involved to understand how it works and identify potential problems.
so it's not just a testing technique, it's also a communication tool.
Precisely. I've seen state transition diagrams used effectively to explain complex system behavior to stakeholders who might not have a technical background. It helps bridge the gap between developers, testers, and business teams,
Right.
fostering a shared understanding of the system's functionality.
That's really valuable.
Yeah.
I can see how this could lead to better collaboration and ultimately a more successful product.
And another benefit that's worth mentioning is its contribution to efficient test case design.
Okay.
By analyzing the state transition model, testers can create targeted test cases that focus on the most critical paths and potential points of failure.
Yeah.
This leads to more efficient testing, allowing teams to cover more ground in less time.
So it's not just about testing more, it's about testing smarter.
Exactly. State transition testing provides a framework for prioritizing our testing efforts, ensuring that we're focusing on the areas that are most likely to reveal defects.
This has been incredibly insightful. I'm starting to see the bigger picture of how state transition testing can be a game changer for software development.
Yeah.
It's not just about finding bugs, it's about improving communication, optimizing test design, and ultimately building more robust and reliable software.
And remember, the principles of state transition thinking can be applied beyond software development. You can use this approach to analyze any process that involves distinct states and transitions from simple everyday tasks to complex business workflows.
It's a really interesting thought. I'm already starting to think about how I could apply this to my own personal projects and even my daily routine. It's amazing how a seemingly technical concept like this can have such broad applications.
It's a testament to the power of systematic thinking and visualization. By breaking down complex processes into their constituent states and transitions, we gain a deeper understanding of how they work and can identify potential improvements.
This deep dive has been truly eye-opening. We've covered a lot of ground, from the core concepts of state transition testing to its practical applications, benefits, and even its limitations. But before we wrap things up, I'd love to hear about any real-world success stories or case studies where this technique has been particularly impactful. Have you encountered any situations where state transition testing was instrumental in solving a challenging problem or preventing a major issue?
Oh, absolutely. I've seen firsthand how powerful this technique can be. One particular case that comes to mind involved a complex e-commerce platform I worked on a few years back.
Okay.
The checkout process had multiple steps integrations with third-party payment gateways and various shipping options,
Right.
making it a real challenge to test thoroughly.
That sounds like a testing nightmare. I can only imagine how many different scenarios could occur in a system like that.
It was definitely complex. We were struggling to keep track of all the potential paths and edge cases,
Right.
and we were finding bugs late in the development cycle, which was costly and time-consuming to fix.
Yeah, that makes sense.
That's when we decided to introduce state transition testing.
So you create a state transition model of the checkout process.
Exactly. We started by mapping out all the possible states a customer could be in during checkout,
Right.
like shopping cart, shipping information, payment selection order confirmation, and so on. Then we identified all the events that could trigger transitions between those states, such as adding an item to the cart, selecting a shipping method, entering payment details, or confirming the order.
And I'm guessing that process of mapping it all out revealed some potential issues that you hadn't considered before.
You're absolutely right. As we started building the state transition diagram, we realized there were a few scenarios we hadn't accounted for.
Yeah.
Like, what happens if a customer tries to apply information?
Oh.
Or what happens if the shipping address is invalidated after the order has been placed?
Those are definitely edge cases that could easily slip through the cracks without a systematic approach like this.
Exactly. And by identifying those issues early on, we were able to address them before they became major problems. We also used the state transition table to create a comprehensive set of test cases, ensuring that we covered all the critical paths and transitions.
So not only did state transition testing help you find those hidden bugs, but it also streamlined your testing process and made it more efficient.
Precisely. It was a real game changer for our team. By adopting this technique, we significantly reduced the number of defects found later in the development cycle, saving us a lot of time and money.
Right.
Plus, it improved communication within the team as everyone had a clear understanding of how the system worked.
That's a fantastic example of how a seemingly simple technique can have such a profound impact on a complex project. It's not just about the mechanics of testing. It's about shifting your mindset to think systematically about how the system behaves and all the potential interactions that can occur.
Couldn't agree more. It's about understanding that software isn't just a static set of code.
Right.
It's a dynamic system that constantly transitions between different states based on user input and external factors. And by embracing that dynamic nature, we can build more robust and reliable software.
This deep dive has been incredibly insightful.
Mhm.
I'm definitely going to be applying these principles to my own work going forward. But before we wrap up, is there anything else our listeners should keep in mind as they explore state transition testing?
Yeah.
Any final words of wisdom?
One thing I would emphasize is that state transition testing isn't a one-size-fits-all solution. It's a powerful tool,
Right.
but it's not always the right tool for the job, as we discussed earlier. It's most effective when dealing with systems where the sequence of events is crucial. If you're working on a system where the order of operations doesn't really matter, then other testing techniques might be more appropriate.
That's a great point. It's all about choosing the right approach for the specific system you're working with. And even if you don't formally create diagrams and tables, the core principles of state transition thinking can be incredibly valuable in any software development project.
Absolutely. By simply thinking about the states, transitions, events, and actions of your system, you can gain a deeper understanding of how it works and identify potential issues early on.
So as we conclude this deep dive into state transition testing, here's a final thought-provoking question for you to ponder. Can you think of a system in your own life that could be analyzed using state transitions? Maybe it's your morning routine, your workflow at work, or even the process of cooking your favorite meal.
That's a fantastic challenge. I encourage you to take some time to reflect on the processes you encounter in your daily life and see if you can break them down into their constituent states and transitions. You might be surprised by the insights you uncover and the potential for improvement you discover.
I love that it's a reminder that the concepts we've discussed today aren't just limited to software development. They can be applied to any process that involves a series of steps and transitions.
Huh.
So embrace the power of state transition thinking experiment with different approaches and see how it can help you build better software and optimize the processes in your own life.
And remember, the world of software development is constantly evolving, so stay curious, keep learning, and never stop exploring new techniques and approaches.
That's all the time we have for today's deep dive. We hope you've enjoyed exploring the world of state transition testing with us. Until next time, happy testing.